In this video, we're going to look at some concepts related to hypothesis testing. Let's look at a research example of an actual hypothesis test. So let's assume for a moment that we are a group of football coaches or statisticians, and we're interested in the research question, did our total offensive yards per game significantly differ from the 2015-16 season to the 2016-2017 season? So if we want to take a look at that research question with hypothesis testing, there's actually going to be a couple of hypotheses that we're going to write out. The first will be our research hypothesis, what we're going to call the alternative hypothesis, designated H sub A or H sub 1. And so we as the researchers, the statisticians, the coaches, maybe we believe that one of those seasons that we significantly outperformed, or that's what we want to assess. Whereas the alternative, the inverse of the alternative hypothesis is what we're going to call the null hypothesis. So if we are saying as the researchers that we believe that we had significantly more yards from one season to the other season, our null hypothesis would state just the inverse of the opposite of that, that there is no significant difference, or in essence, that those two seasons are the same as one another in total offense. If that's not confusing enough, let's go ahead and break that down in a picture format. So if we look at 2015 to 2016, maybe for example, we had 376 yards per game of total offense. And in 2016, 2017, we had 389 yards per game. And so what we're going to do is with our alternative hypothesis, that's what we as the researchers believe, that we're going to say that these are not equal to one another, or that they are significantly different from one another. And so as we mentioned, that's our alternative hypothesis. And then if we take a look at our null hypothesis, we would say the inverse of that. So in essence, these two seasons are not significantly different. Or in other words, they're equal to one another. And it's this null hypothesis that we're going to evaluate in regard to hypothesis testing when we run our statistical analyses. So when we run the statistical analyses, we're going to get one of four, we could come up with one of four outcomes here. So when we evaluate the null hypothesis, let's first look at if we find that the null hypothesis is in fact true, that there is no significant difference. So if we fail to reject when there is no significant difference between the means, that is the correct decision. But what if we say that the null hypothesis is false and we fail to reject? Well, what happens there is we come up with what's called a type 2 error, and that's assessed using beta. Well, what if we reject the null hypothesis when it is actually false? Well, we'll get to type 1 error in just a moment. But if we reject the null hypothesis when it's actually false, that's the correct decision. But if we reject the null hypothesis when it's actually true, this is the more serious of the two types of errors, and this is what's called a type 1 error. And in statistics and in hypothesis testing, we try to minimize the risk of committing this type 1 error. And so this type of error, type 2, was assessed with beta. Type 1 error is assessed with alpha. And so we try to reduce that risk. In the social sciences, for example, oftentimes we might set alpha, our a priori alpha, before the study at maybe 0.05 or 0.01, or even more stringent would be 0.001. And so what we're always looking to do is to reduce the risk of this type of error. What some students believe is that once we come up with our test statistic and we interpret that, and if we reject the null hypothesis, that's the same as accepting the null hypothesis. And that's not actually true. What we're looking at here is we can only have two options for the null hypothesis. We either reject or we fail to reject. We never accept the null hypothesis. That's just bad science, because there's always some degree of uncertainty or probability associated with an error rate. So we're never 100% certain in our results. There's always some degree of error there. So in essence, we either reject the null hypothesis or we fail to reject the null hypothesis, and one of those two being in favor of the research hypothesis. So that's a little bit of an overview of hypothesis testing.